And one topic that seems to be on everybody's mind, and I can certainly understand that, is security. And specifically, we're talking about things like network security and the ability to penetrate or breach a FrogNet, especially as it would happen through the greater internet, and what could happen were you able to do that? Were you successful in penetrating a network like this? And addressing this issue is a multifaceted approach, but it's rested or its foundation is in the architecture. The systems that we're dealing with now are ones that were, not they are not significantly different than the ones that I was dealing with in 1985 when I was working with Boeing, and we were doing some of the very first, uh, communications tests. At least for Boeing, and the people on the internet were scholars and business people and researchers, and we might have had need for spam filters, but we weren't going around attacking each other, not maliciously. All that, of course, has changed since then, and now we attack each other on a pretty much on a minute by minute basis, is what it seems. And so, as a result, uh, we have all of this security infrastructure that's been bolted onto the systems and and made to kind of work. I mean, we've sort of folded the systems around the security architecture instead of using a an architecture that included security in the beginning. And that's what FrogNet is. So what do I mean when I say included security? What I really mean is it doesn't do the stuff that the 1985 system does, right? Um, it doesn't open up those those vulnerabilities for a couple of reasons. Um, those vulnerabilities that we're talking about are all internet-based vulnerabilities. That's really, the 99% way that systems get penetrated is through the internet, and there the majority of them are broken into by social engineering. But there is a class of problem that has emerged recently and is becoming more and more of a threat. There are AIs in the wild that have escaped into the wild that have the ability to attack websites, to compromise the websites quickly and get in and steal whatever they want. And the responsible AI vendors are not releasing those, but that's cold comfort because we know that there are plenty of irresponsible AI vendors, and this stuff is not going to be kept under lock and key for very long. So the best way to protect yourself against this and many other things is to simply remove your attack surface from the internet. And what that means is you remove all of those open ports that you have right now. You remove all of the messaging stuff that you've got going back and forth among the machines that are in your network, and you instead replace them. I mean, you don't remove them. Actually, you just remove them from the internet, and you do that through the simple task or through the simple, uh, uh, yeah, I guess, solution of inserting a FrogNet uh, in between your network and your egress point, right? So you've got your own 10 dot network sitting out there and it's doing your own thing and all that. All that's great, and you've got an egress point to the global internet. If you put a FrogNet in there, such that the FrogNet is the one that globally egresses, and the network that you have gets their addresses from the 10 dot network, from the FrogNet 10 dot network, then then you have a FrogNet network underneath the external network, and the only way you get through the to the FrogNet network from the internet is through the broker. And if you recall, a FrogNet network talking to another FrogNet network on the other side of the world uses the broker. It uses WireGuard tunnels going through the broker, and WireGuard tunnels by themselves are fairly secure. They're encrypted, and they don't respond to uh, probes, ICMP probes, or I think even UDP probes. But they just don't answer to it. So you really kind of don't know that they're there. So those are the WireGuard tunnels, but we still have to have one open port on the broker, so that unclaimed, uncertified machines can contact it. So to mitigate that, we let you put the broker on any IP you want. Right? It's a Linux thing. You just get yourself a DigitalOcean droplet, or you get yourself an AWS thing or Azure thing, and you just say, "This is my broker," and you drop it on there. You don't give it a name, don't do anything, just keep it an IP address. You just drop it on there, and you you also decide the port that you're going to use. I used 18275, but you can use any numbers you want. Don't recommend something down in the low range, uh, especially not like 53 or 80. but but you can choose your own, right? So that those are the first two things: is that your broker is on a random machine somewhere on the internet, and it is on a random port somewhere on the internet. And yes, there is a possibility that that machine can be probed. And so if we look at the probe, uh, the probe you would use is probably the Nmap probe, right? That's probably what I would do. And so what we have here, this is the Nmap probe here. Now the machine that this is on is actually a FrogNet machine. This is not. So we're going to do the Nmap probe here. And when it's going to come back is show that that on this machine port 80 is open, which is true because that's my website, but that has nothing to do with this. Uh, Here it is. So we have 80 open, we have 443 open. That's cool. That's my website. Nothing to do with the broker. We do have 18275 open, but its service is unknown, and the junk that came back with it is garbage. And so that it says the service detection was performed, and you can't do it. So if we then do a curl SV to the endpoint and the address on the endpoint, what you get back is the header information only. This says this is streamingfrog.com at 18257. So yes, there is something answering that port, but you're not getting any identification. It doesn't say who it is. It doesn't even say what the Apache version is. And more importantly, this is not a way in, right? This is not a way, you can't break into the broker through this pathway. Now, let's say you could. Let's say you could manage to get into the broker. You send it something that caused a buffer overflow, and you managed to get into it. The broker is not a member of any of the FrogNet networks. that you're working with. That's a rule. It's not a member of them. So since it's not a member, you still have no egress point. You took over the broker. Congratulations. You can tell me what the semantically compressed data going across the wire from one machine to another machine is. The data never touches the machine in the broker, right? I mean, it touches the machine, but it never touches the disk. It's not stored in any way. So the data going through the broker is ephemeral. The broker handles it strictly through IP tables, and again, there is no history. So it is completely anonymous and really pretty much unattackable. And if you do manage to attack it and compromise it, we will congratulate you as we stand up a new broker somewhere else that joins our networks together. So the the security on FrogNet, the external security is built into the system, but it's built in by nature. It's built in by the architecture of the system. Beyond that, the fact of the matter is that a FrogNet host is a general purpose computer, right? It might be a Pi, it might be a MacBook, whatever, but it's a general purpose machine. And the architecture of these machines is also well known. And the way that you protect these machines is also well known. So on mine, when I put them together, I didn't do any 443 or anything like that. You can add all that. You can add certs. You can add a CA. You can add, whatever you think you need to be secure in your, body and spirit. And it doesn't matter, right? I mean, one thing I would definitely do is make sure that your Wi-Fi passwords are properly stored and properly maintained, right, as well as rotated, so so people can't break in through the Wi-Fi, because that's really, from my point of view, the vulnerabilities of a FrogNet are essentially human, right? Social engineering. If they manage to get somebody to give them access to a machine, that's the kind of thing that's going to cause real problems. But other than that, security is, as I say, it's inherent in the system, and the system is one that does not, uh, you know, does not work the same way that existing systems do. So they don't react the same way, and what the attacker expects, they're not going to get. And then if they do get in, we'll give them a hearty handshake, right? So let me know if you have any questions about this. I am sure that what we've got is going to be, virtually impossible to break into, but go ahead and try, right? If you can make my Oracle red, uh, I will happily admit that I am wrong. So, uh, good luck. Bye.